right, thank you. Well, on the great side, it's only a 30-minute talk, and it's the last one of the day, so that's nice to look forward to.
We love you already.
So this big talk, what's it all about? It's basically how do you make D fit in an ecosystem where there's lots of people going on. Maybe you're in a company, there's lots of competing different programming languages. You want everything to play nice. Maybe there's legacy code. So how can you use existing tools to make your life easier? That's kind of the gist of it. So it's broken up in a few sections, which I'm going to get into. And also, who am I and why should you even care? So my background and my perspective, recently I've been spending a lot of time in Java, but it's mostly solving business problems under time pressure, and that influences my perspective and how I approach things. Lately, I've been trying to form my own business with D kind of as the heart of it, which is a great way of putting yourself in a position of these are some practical problems you need to solve very quickly. It's turning D into a practical language you can use. So I had this system I was working on. How did I get into this thing? I was building a service called Funnel, which is like a very high performance data store. You can think of things like taxi services, micromobility, need lots of data to put into the system and query for it, and D is a great language for this stuff. So you got a good product, you're out there, how are people gonna pay for it? Well, I don't want to write a credit card processor from scratch all over the place. That would be not exactly the best use of time. So how does everyone else do it? Oh, well, they use services out there like Stripe, for example. Okay, well, how do you interact with Stripe? Well, Stripe's got like this nice big old API out there, but it's enormous. It's really, really big, and converting it and building my own client would take an inordinate amount of time. So how do other languages solve this problem? Well, they got these nice clients on GitHub and other places. Well, how do they write them? They generated them. They didn't write them. Automation is the key to what they do. So does D have a tool to generate this kind of stuff? No, but it could. And this is where we're going to get into some of the standards that are out there and how you can make them be your friend instead of your enemy. So the context of this problem is companies often have very useful services, and they often depend on services in the outside world. Maybe you need to accept credit card payment with Stripe. Maybe you're using large language models to do sentiment analysis on customer reviews. Or maybe you're just writing a bot to integrate in Slack and tell you when your builds are done, that kind of stuff. But writing these clients by hand can be very time consuming and error prone. And you got better things to work on. You don't want to spend your time maintaining these clients and keeping up with every single change in the API. Not only that, but inside your company, there's other problems to deal with. Not everyone's using the same technology pieces. And you got to have an interface that is secure, it's simple and easy to understand, and may potentially need to support multiple programming languages. Companies have all sorts of reasons for using different programming languages. One could be because the initial founder liked a programming language and that's being used. Or maybe the local talent pool, you can only hire programmers in this area that are using Python or TypeScript, and then later on you switch. Or maybe you run into specialist problems that need languages to solve them, like most of your systems in Node.js. But then you're also running a piece of your system that's like a real-time auction or like a credit card authorization system that needs to run very quickly, and then you use a specialized language like D or Rust or Go or something for that performance critical part. So you often end up with this heterogeneous environment. So in order to get these things to talk to each other in a fairly standard way, you need a protocol that they all understand. And a common way of doing this is this notion called REST, which stands for Representational State Transfer. And it's like an architectural style, but it's loosely defined exactly what it means. Like you're describing like nouns, like things by URL and actions you can do on them, which are like HTTP methods like post and get. But the exact protocol of what data you're transferring, whether it's JSON or Apache Avro or protobuf, it's not exactly determined, and you can't precisely document what it is in a consistent way that everyone understands. It's a little bit on the vague side. So what's OpenAPI? You likely have heard of it in its earlier forms because it used to be called Swagger and was developed previously until it was adopted by the Linux Foundation in 2016. At this point, it became a widespread standard that's not just in its original language it was built for, but it can be used for other things. It's often used to describe API interfaces in a programmatic way, and because it's standardized, that means there's tools you can get for free. It's built on top of an older standard called JSON schemas, which are ways of like describing how do you actually have validation of JSON data, which by its nature is not really well formatted, not precisely defined. It doesn't have the equivalent of an XML schema. So the JSON schema was an attempt to standardize this, and the Swagger API, the OpenAPI system, builds on top of that. So there's a lot of services that do it. You can go to websites like apis.guru, and there's about 2,500 and counting services that are using it. Whether you need something for banking or you need any other service that's out there checking weather information, chances are very high they're going to be using an OpenAPI specification. So if you want to interact with the outside world, that's the place to go. And because it's a standardized format described in a specification, you can use tools no matter what language they're written in. So if I want a tool to visualize my API for my QA team to actually use, maybe they don't use D, maybe they use another tool that's out there. You can take advantage of documentation generating tools used by someone else in your organization, and you get to the endpoint, the goal you want, without any effort at all. So this is an example of a tool for Swagger for taking the OpenAPI specification of a tool and turning it into like a web page that's clickable. You can expand it. You can get descriptions of all the parameters that are out there. So if you want people in your system to quickly learn how to use your system, you can get nice, pretty graphical interface for your documentation very quickly, presuming you described your interface using the OpenAPI. So what is this specification? Like, what is it? It's a JSON document at its heart, or you can write it in YAML. They're convertible to each other. And at the top level, some of the most important pieces of data inside of it is just the description of the servers. So when you publish a service that's out there, you're actually including things like what is the URL, what is the domain of the service out there in the world that's actually providing this. You're also saying how is it secured? Is it with basic HTTP authentication and password, or is it using OAuth 2, something else? And then you describe your endpoints as paths, and as you describe your endpoints as paths, there's often a lot of reusable pieces of data. Maybe I have the same error structure that's used by like 50 different endpoints. All that common logic goes in this section called components, and here you can define things and then refer to them later on when you're defining your paths. So here's an example of what the actual contents of a piece of an OpenAPI specification looks like. I believe this one is drawn from some of the OpenAI officially published specification. And in this case, they're looking at the paths, and there's a path called files. And it has this little parameter in curly braces called file ID. And then inside of that, you have methods that are basically split by method. There's post, delete, all that normal stuff. And in this case, you just give it a unique name, which could be used to define a function, or in your documentation, you can tag it. So in this case, they're just tagging with OpenAPI. But tagging is great for things like helping people search through your documentation. They can search by tag, or you can group things with the same tag together for display purposes. And then you include things like the parameters. So in this case, we saw this little curly brace thing up here, the file ID. It's described down here. So there's a parameter named file ID. Where did it come from? The path. Where else could it have come from? It could have come from the query string, the thing after the question mark in a URL. It could have been like in a post body. So you can basically describe where the parameters come from, and this becomes part of the specification. So this is built on, I mentioned before, these JSON schemas, and JSON schemas allow you to just say, what should this look like? And it's a little bit different from the D programming language, because when you have data types in D, there are primitive types like integer and Boolean and whatnot. And then if you want more complex types, you can group them together with, let's say, a struct, or you can have a list of them using an array. It's a little bit different with the OpenAPI spec, because the way it's done is it's a list of assertions that must be specified. So if I have two complex descriptions, it's not like multi-classing. It's more like both conditions must be satisfied. So it's almost like I'm like the intersection of these things. And so the types don't neatly translate into D. But some of the weirdness that you can express in JSON schemas is often not done in real life. In real life, most of the time, they have specifications that do fairly neatly translate into D structs, D classes, arrays, etc. So in this case, we have another example schema of using the reusable parts. So I mentioned components, for example. So when you're writing your specification, you can actually create data types that you can refer to. And in this particular case, we have one called create chat completion response. This is another example drawn from OpenAI. And what they're basically saying is, in order to specify this object, that's what they're saying here, type is object, it must have the following properties. So it has the properties ID, model, and choices. ID is a string, model is a string, choices is an array, and it's an array of objects. This word items is used to describe the contents of an array. And so over here on the right, we have an example of a data structure that satisfies the conditions on the left. It has the ID, which is a string. It has the model, which is a string. It has choices, which is an array of things, which are themselves objects, which have their own fields that are required. Index, message, finish, reason, as in this particular example. So it's very formulaic. It's kind of a one-to-one mapping of how this works, and which means it's great for code generation. Getting these specifications and turning them into D code that you can use as a client is not nearly as hard as you might otherwise think. So in terms, at the primitive level, at the base of these JSON schemas, there's two data types that are related. There's a type and a format. So in this previous example, we had types like string and a few other ones. You can have other types like integer and number, which have very much like JSON-like interpretations, but they're combined with this other thing called a format. And the format basically just bridges the gap, because in JavaScript, types are a little bit vague about what they mean, how many bits do they represent, and so the format narrows it down. Is this meant to represent a date? Is this meant to be a password? And things like this, like, well, password's not a special data format, what's the point? Well, the point is if you have tools that are automatically generated for like entering passwords or doing anything like that, it's a hint saying, oh, maybe you should hide this in UIs where users may enter a password, for example. So it just basically says, how do you interpret the raw data format? And you can define types in a very common way under this section called components. And the components lets you just make reusable pieces, like I mentioned before, common error codes, common request data structures, common response data structures. And inside of it, you can define common components which are grouped by either for schemas, for the response, parameters, request bodies, headers. Everything here is based on web request, and you're just breaking down the reusable data structures for that purpose. And how to actually make use of it. Once I define a reusable piece, what do? You basically are defining a reference to one of your data objects using this special format, which is defined as part of the official specs for JSON schemas. And you just have a special property called $ref, and then you refer to it by path. And this is essentially, how do I drill down into the JSON document to find this thing I defined? So the hash symbol just means the root of the document, and then you're basically going back down. The section where you keep reusable pieces, that's the field called components at the top of the schema. And then it could be things like, it could be reusable schemas, it could be requests, it could be parameters. So you just drill down the JSON schema until you get to the name of your piece, and that's how you use them. So then there's the other question. If you're developing a complex project, how do I manage these specifications and where do I generate them? Because there's a lot of different options for this. The two big pathways are when should I create the OpenAPI specification? Should I start with my code and extract information from my code and turn that into the spec? Or should I start from writing the specification and then generate code to interact with it? There's different people with different opinions, and there's no right answer. You just get different properties depending on what you chose to do. So this approach of generating a specification from code, it has some advantages. So it's very easy to keep it up to date. As you update your code, your compiled code that's been checked, the specification is always kept up to date. And you get a lot of support from language-specific tools. Like if you're using Java, there's a project called Spring Doc, which is doing a lot of this. And yeah, you can also go in the reverse direction and just generate code, and it has pros and cons as well. Now, in this direction, if we use our code to actually generate our specifications, It works great in very simple cases. I have my code. The code is used to generate the spec. The spec makes its way into customers' hands. All is simple and nice. But as your company grows and complexity grows, you start running into other problems. So let's suppose I'm actually introducing things like Python or D, and I actually have multiple projects that are working together to provide an interface for my customers. Well, if I happen to use a tool that was generating my specification from my Java code, how do I incorporate other projects? If there's no consistent tool chain that actually gets everything deployed to where it needs to go, changes are harder to keep up to date, and it can be a little bit tricky. Another approach is to turn things around a bit, is by starting with managing an OpenAPI spec and then have clients in your code be generated from that spec and then also publishing that spec to external players. This makes it easier for you to plug in projects that are in different languages, including D, and have them live in a coherent ecosystem with the rest of your services in your company or organization. Here's an example of why it can be a little bit tricky to generate specs from code, because all the information that's in the specification, if you're generating it from that code, that information has to live somewhere. This includes documentation, exceptions, use cases. This is an example of Java code where the API spec is actually buried in the code and extracted from these annotations. But as you can see, the code gets a little buried. It's kind of hard to see what you're working on when you do things in this way. And it can actually go back and have a negative impact on your productivity of writing your project because your project's code gets a little buried under these things. So in terms of writing something that works with OpenAPI and D, what's so good about D? What makes it useful to actually help generate code? And D is actually a wonderful language to generate code from just a very small number of features that you can reuse in novel ways. So one of the most common ways of doing is a mixin. So mixin just lets you take a string description of a piece of code and insert it as an actual code. It just gets embedded right in. Now you might think that, oh, it's a string. What if I have a typo or something like that? It is actually checked for syntax validity. So if you get something wrong, it will let you know right away. It looks a little ugly, but it is safe and it does work. The times where you want to really use this is when you need to do something that affects the name of what you're working on. Like if I'm generating a function and I need to modify the name of the function based on a variable or create parameters, mixins are a great way of actually having very precise control over exactly what something is called because it's string manipulation. I can take a string in from the OpenAPI specification and make a function that has that exact same name without any trouble. Mixin templates are similar in the sense that they're generating code, but the difference is you can take a block of statements that are parameterized like a template, and they get embedded right in the same place where they're called. They don't have a separate scope. The code gets inserted right away. And you can combine it with your previous use of mixins. So what we're doing in this particular case is we're just having this mixin template called add field. And in this particular case, I'm adding it to, let's say, a class. And I know the type of the field, and I have the name of the field. So in this simple example, what I'm doing is I'm declaring the field to be a variable as a statement, and then I'm adding a setter function. And the setter function itself is actually a templated function. By itself, it seems kind of useless, but we'll use it again for something slightly more useful. So in this particular case, I have this class called fish, and I'm basically saying I would like to add two fields, a nullable field called age and a nullable field which is a string. And in this case, I can just have a fish, and I've not only have the data fields defined, but the two functions that were defined over here, the setters, are now available as well. So I can create a fish in a way that's kind of in a builder-like fashion. I have my fields defined, I can call my setters, and I'm good to go. Static for each is another feature that's extremely useful in D, and like the mixin template, it embeds itself in the place you call it, but instead of just a single statement one at a time, for every single time that the loop iterates, it embeds that code directly in this context. The reason why this is so useful is you can do things like at compile time, what are the list of functions that I have in a class or a structure? What are the list of members? What are their types? And you can do objects, you can insert objects based on that. So in this particular case, instead of just adding the setters one at a time, I've made a dedicated mixin template for this. So I'm iterating over all the fields of a class, and for each one, I'm calling the add setter function we defined before. So I just say, I want to add setters to a class. I want to declare my fields, and then I want the setter functions to be called automatically. And the setter functions themselves, all they basically do is set the field, and then I can actually return the class itself, so I can call it in using like a builder pattern. And of course, you can do things like not only look at my class fields, but I can also go up the inheritance chain. So if I have a class that inherits from another and from another, I can actually automatically generate a setter for every attribute, no matter where it is on the inheritance chain. And using it again, in this example, I have a class, I have something that inherits from it. I just say add my setters, and now I can create this builder-like pattern in one go. It just creates the code for me. And this is really great because if you have a textual description of the kinds of functions you need to create or usage patterns, instead of generating all the code again and again and writing it and maintaining it, you can just use a few compile time mix-in templates to generate large swaths of code to make your code much, much easier to deal with. So making use of these features, and given that I wanted to basically do Stripe processing and call other APIs, there's a project out there called OpenAPI Client. And it's basically making use of these specifications to generate decode for you to use. So the way it basically works is you find some company that publishes an OpenAPI specification, some service you want to use. In this example, we're going to be using OpenAI. And you basically just run the project to generate the D client code, which is now callable by your application. And then you call the service that's out there in the real world. And that's kind of the goal, to keep it as simple as possible. So in this particular case, like step one is I want to get an OpenAPI specification. So in this case, OpenAI offers theirs available on GitHub. And so you can just download it. Theirs happens to be in YAML format, so we just convert it to JSON. And in this case, we just run the tool. We say, where is the file that is the basis of our API? And what is the root level module for your client? And that's it. The code is done. And so what does it produce? There's objects that are created, like request parameters, this kind of stuff, and the code ends up looking like this. It's based on Vibe. I know people have different opinions of different web clients they use, but these kinds of things aren't super hard to change. It's mostly, I need to make a call to someone out on the internet. So it's using the Vibe tools for that. So it has a mapping. This is basically for the JSON serialization. So this is very useful because sometimes an API will include a keyword, which is a D keyword, and you don't want to declare a variable with a conflict in the name. So it resolves that clash, but then keeps the name for serialization purposes. In this case, it's an optional field, so it uses the standard library nullable for that. And it produces just normal objects. These comments over here, this documentation, these are pulled straight from the OpenAPI specification. So maybe you're writing some code, you're trying to get some code completion or just look at what comes next. You just pull out the documentation, you're good to go. So it works very friendly with a developer environment. The basic rules are, if it's optional according to the OpenAPI specification, it becomes nullable. If it's an object that's kind of embedded and it can be used, it's a static inner class. All documentation from the spec is included in, and every object that you can create is you following a builder pattern, which we'll get to a bit later on how this makes it easier to call web requests. So in the second major thing that it can create are services. These basically map to groups of endpoints that I want to call. And they're usually broken down into, here's the name of the endpoint, which is pulled from the OpenAPI specification. In this case, it's an image edit. And you basically say, well, what are the parameters that I want for my request, and how am I going to deal with the response? And the deal with the response is you can have many responses. You might get a HTTP code 200, which is successful, and it has one response. Or you might get an unauthorized error, like a 400 type error, and that has a different body. So the idea is you write a handler function, which is typed, and with the type coming from the OpenAPI specification, and you say, for each type of response, what should I do? So here's an example of the usage of it. So in this case, I have that I want to call OpenAPI, and I have this create a completion service. So I want to know what's the cutest breed of rabbit, for example. You include in the request the model, saying what the name of the model that I'll be using, all your parameters, and this is just created in line. So I'm calling the create completion function, but I'm just building my request in place. And then I'm basically saying, how do I want to handle the responses? So in this case, I have the handler type. And this is what I want to do in if there's a 200 response code, but there could be other response codes, 400, 500, et cetera. You just fill in the logic for each one, and that's it. The usage is basically that simple. The response I get in this particular example is a little bit funny, and they talk about the different types of rabbit breeds and how there's many opinions about which breed of rabbit is the cutest, but the thing is, it works. That's the main purpose of this slide, is that you very quickly get a response that you can use. So future plans is that while it's nice to actually develop something that works and solves the problem, in the long run, you want something that covers every single corner case, and there are open projects out there like OpenAPI Generator, which has like a list of like 20 or 30 programming languages that it supports, and I would like to actually add D to that list. And yeah, the other option to consider is to go with the code first approach and maybe adding API integration annotations to something like Vibe, although truth be told, it's not my favorite approach. And that's basically the gist of it. So thank you for your interest and attention.
All right, last questions for the day.
Couldn't help but notice that when you're showing the specifications that it's basically a stringly typed API. For instance, at one point it has type string. So if you misspell that, oops. Wouldn't that suggest that it's better to start with the code and then generate the spec from it?
You mean the API itself?
Yeah. So in the specification, for instance, you had this is an array. The items are objects. So if you misspell any of those things, it's going to be easy to make an error. And so the question is, doesn't that suggest that it would be better to start with real code and generate that instead of the other way around?
It depends on the problem you're facing. If you're working in a single language environment, you might find it more convenient to simply start with the code first, if you don't have to worry about anyone else. It really becomes more of an issue when you're working with different things. And often with D, you're the minority language. You're the new person to the party, and you want to say, hey guys, you don't have to stick to one language. You can work with D as well. And at that point, making the specification king gives you an opening for other languages like D as well. Also, when you run the tools to generate interfaces, you'll get an error then.
So when OpenAI changes their API, they add a new endpoint or something like that, you're relying on the community to realize that and then regenerate the API?
Yeah, and normally this is pretty normal for companies because a lot of companies, they have people using handwritten clients. And so when they're modifying their APIs, they pay a lot of attention to make sure it's backwards compatible. So often if they're going to have to make a big change to something, what they'd rather do is add a new endpoint and then basically don't kill the old one until you can make sure that your users no longer are calling them. You got to give them proper notice periods, let them migrate. So the whole process, once you have a public service available, is quite deliberate.
So I didn't quite catch how the built-in code generation tools that D provides are relevant for this project.
It's basically, it makes it simple. So because D is so good at basically allowing you to put together code, it's a mixture of just generating source files, but even the source files you generate can reuse bits of code for generating code. It's just less effort. So just one dude with a couple of hours and you're good to go. It doesn't have to be a complex effort like it is in other languages.
Makes sense, thanks.
In the Java example you showed, it was basically the API is defined through all those annotations. I think I've seen similar things in Python as well, right? Where it's not really generating the spec document from the code, it's generating it from the annotations. Can you see a mechanism can you see a way in which you can lean, particularly in D, that you can lean more heavily on the code to generate the API spec? Or do you think you're also going to end up with a load of kind of annotation, pragma, pseudo comments in order to fill in some of this stuff?
the information you need when mapping to an API specification, it's quite a bit because you have to handle like all the different data types, and the data types vary based on the response. Is an error response, is not an error response. And what makes it further complicated is the full power of the OpenAPI specification doesn't cleanly map to a programming language either, because instead of having like clean inheritance with structs and class and whatever, it's just like a list of validation steps that have to be applied. So it could be a bit messy. You can do this though with D. You can do that approach. And it's very viable, but it would be very like framework specific, because how do I specify answering an HTTP request? It'll be different in Vibe versus another web framework, and that work will have to be repeated for every type of framework that you have.
Cool. I think we can call it there.
All right.
Good. All right. Thank you.